Who would have ever imagined that something as simple as an apple falling on a man's head would have inspired a man no less than Sir Isaac Newton into many startling scientific discoveries? Hoping to stimulate young minds in the same manner, we are back with your favorite inter-school science quiz show, Quest. Quest, as you know, is brought to you by Doordarshan Kendra, Kolkata and the National Council of Science Museums. So before going any further, let me welcome the Director of National Council Science Museum Headquarters, Dr. Jayanto Sthanapathy. How do you do, sir?
I'm fine.
And now introducing the teams to you. On my right are the J.C. Bose team. You are?
Radha Abiswas from Loreto Day School, Sealdah.
Shubhasri Ghosh from Loreto Day School, Sealdah.
Vidya Mukherjee from Loreto Day School, Sealdah.
Let's give them a warm welcome. And on my left are the C.V. Raman team, and you are?
I'm Shaunak Chatterjee from Don Bosco School Park Circus.
I'm Rahul Chatterjee from Don Bosco Park Circus.
I'm Goirik Sharkar from Don Bosco Park Circus.
The rules of today's contest are fairly simple, 7 questions in all. The first 4 are direct, that is 2 each to both the teams. The last 3 on the buzzer. 20 points for every question answered correctly if it's a direct question, 10 points on passes. When we get to the buzzer round, I'll explain the rules of the scoring system there. So let's move on to the very first question of today's episode of Quest. And now the first question, this is for the J.C. Bose team. Dr. Sthanapathy.
Now the question. You have seen a toy boat floating as well as moving forward in the tub. My question is, which are the physical principles involved in flotation of the boat as well as its forward movement?
For the flotation, the principle of buoyancy is involved, and and for the movement, the conservation of momentum.
Newton's third law.
Could you explain with
at
little more details?
At first, when the boat is just at rest, the momentum is 0. But when when water boils and it comes out to the second hole, so it do so with a velocity, and it also exerts an equal and opposite reaction on the boat, and that is why the boat moves forward. And since these two velocities are equal, the momentum will be 0, and it can also be explained from the Newton's third law of motion, because
yes, that's absolutely right. This is moving forward because of Newton's third law of motion, and it's floating because of Archimedes' principle. That's absolutely right. So they get full marks for the question.
Great answer there, girls. You pick up 20 points. And we now move on to a better explanation from Dr. Sthanapathy.
No, they have given the correct answer.
They've given
so I don't want to add anything more to that, what they have said.
All right, let's have a big round of applause for them then. And the next question is for the C.V. Raman team.
I have 2 oscillators here. I'll switch on the first one. It makes some sound with some pitch. That means it has frequency. Now listen to the other oscillator. Okay?
Yeah.
Now I'm switching on both the oscillators together. Do you notice that the intensity of sound is getting louder and softer? There is a variation.
Yeah.
Why this variation is occurring? Variation of sound.
Go for it.
You answer?
Sure.
Well, there is interference of these 2 sound waves from the 2 speakers.
Okay.
So since the frequencies are different, so are the wavelengths, since velocity of sound is constant. So it's not interfering at equal, means the nodes of the two waves are not interfering at the same time, so beats are produced, and in the end means when the two nodes of the two waves interfere at the one point, then a large amplitude of wave is created which makes a louder sound, and at other times the sound is softer. So
the phenomenon is basically the phenomenon of waxing and waning. When the sound is maximum, it is a waxing. When it is minimum, it is a waning, as a result of which we as the observer are hearing alternate maxima and minima of sound as a result of the interference of two successive antinodes and then two successive nodes. This results in maximum sound at one time when two successive antinodes interfere, and when two successive nodes interfere, it results in a waning.
Absolutely right. You get full marks for that. Now,
great teamwork there, both Shaunak and Rahul. Are any of you planning to become scientists in future life? You are. Yes, Dr. Sanapati.
Only one point I would like to add here. You can hear beats only when the two sources are
Close together
in terms of frequency. Now I'll show you one more thing. You can hear the beat. What I am doing, I am changing the frequency of the other source, which is not fixed, to further from the fixed frequency. And the bit is the difference of frequency between the two sources. If one is 256 and the other one is 257 cycles, then you get a bit of 1 bit per second.
Yes.
Thank you, Dr. Sanapati. Tell me something.
Yes.
If both of them are at exactly the same frequency, what would happen?
Nothing will happen. You don't listen to bits. You listen to a louder sound with fixed frequency.
Can we try that also?
That will take time, but I can try.
All right.
That's it.
Wonderful. Thank you, Dr. Sanapati. So both teams tied at 20 points apiece as we go into the third question of today's edition of Quest. Welcome back. You're watching Quest, the weekly inter-school science quiz program. As you are aware, this is the quiz for students between classes 9 and 12. And the basic objective behind our quiz is to impart education in a competitive manner. But let's not get carried away here. May the best team win. Next question for the JC Bose team.
I have borax, which is dissolved in water. And I am adding phenolphthalein to it. You get pink solution. Now I am adding glycerol to it. The color vanishes. You have to tell me what is the reason for the solution becoming pink and why, due to addition of glycerol, the color vanished.
Hurry up, girls, you have 5 seconds to go.
When borax is dissolved in water,
Right.
its formula is Na2B4O7 and H2O. It produces sodium hydroxide, which is alkaline in nature.
Very good.
And so when phenolphthalein is added, it's due to the alkalinity, the color changes to pink.
Because phenolphthalein is a
Indicator.
is an indicator, right? And in base it shows red color. Fine. Next. How the color disappeared?
Glycerol is base. Glycerol is base. Glycerol base.
You don't know the next part?
Because glycerol is a base and it neutralizes NaO.
No, no, that's not the right answer. Would the other team try?
When glycerol is added to the solution, which is already alkaline in nature,
Yes.
then due to the formation of neutral sodium glycerate, the color disappears.
No.
Glycerol in itself is acidic, so it neutralizes the already alkaline borax solution and phenolphthalein.
And compromises the effect of the color change to make the solution colorless.
That's not the right answer. We have to go into the audience.
All right, neither team getting the right answer. Do we have any volunteers in the audience with an answer? Answer in the audience? Yes, why don't you come up? Come, hold the mic. What's your name?
My name is Bosco. I'm from Vivekananda Mission School.
Yes, and you have an answer to this one?
Yes. And the borax is an oxidizing agent and glycerol is a reducing agent. Borax oxidizes it to an organic acid which neutralizes the sodium hydroxide base and the solution, the resultant solution becomes neutral, and hence the color of the phenolphthalein turns black to colorless.
Your approach is right, but the answer is not correct.
Okay, you can go back. Thanks for trying anyway. Yes, Dr. Sanapati, why don't you give us an answer here?
Okay. You know, when borax is dissolved in water, it makes boric acid and sodium hydroxide. But boric acid is a weak acid, so it doesn't affect the phenolphthalein. Of course, in acid, you don't get any indication in the color of the phenolphthalein. Because of the presence of NaOH or sodium hydroxide, the solution gets pink or red. When I am adding glycerol to that, a chelate compound is formed called borospiranic acid, which is a very strong acid, and due to the presence of that strong acid, the effect of NaOH doesn't remain. So that's why the color vanishes and you get a colorless solution. That's the correct answer, the full answer.
Dr. Sanapati, do we give them any points for half an answer?
I think so. We can give half marks to 𝐿𝐶𝐬𝐽's team.
Scores at this stage: 𝐿𝐶𝐬's team 30 points and C.V. Raman team 20 points. The fourth question of today's quiz is for the boys of the C.V. Raman team.
I have potassium dichromate in this test tube, and to the solution of potassium dichromate I have added solution of few drops of potassium iodide, and the color of the solution is green, yellowish orange. Now I am adding concentrated sulfuric acid to this solution. You get a greenish solution. Now let me add benzene to this solution. After addition of benzene, now we get two liquids. One is pink and the other one is green. You have to tell me why this green color has appeared and why this pink color has appeared.
First, when we took potassium dichromate and then we added sulfuric acid, then along with potassium iodide, then as a result of an oxidation reduction reaction, the K2Cr2O7 was reduced to form chromium sulfate.
Absolutely right.
Which is green in color.
Very good.
However, on the addition of benzene, we find that the solution, the upper part of the solution turns pinkish violet.
Right.
This happens due to the heat of the reaction. In the first reaction, the Ki is partially decomposed, and an addition product is formed with benzene, which is violet color.
Why it is violet?
The iodine dissolves in the benzene.
That's right, because of the iodine. Iodine gets dissolved in benzene, which makes it pink. And in the lower portion, in aqueous solution, we have chromic sulfate. That's right.
Let's have a big round of applause for them then. Dr. Sanapati?
No, they have given the right answer. Nothing more to add.
The boys in the lead with 40 points, the girls still on 30. The fifth question of today's quiz is on the buzzer. Now remember, both teams, if you press that buzzer switch in front of you, you must have an answer ready with you, irrespective of the fact whether the question has been asked or not. Plus 20 if you get it right, minus 10 if you do not get it right. These questions will not pass to the other team and will move straight into the audience. Dr. Stanapati.
I have 3 torch bulbs here. They are connected in some way. They have different colors, red, yellow and blue. Now there are 2 terminals, A and B. A and B. I am connecting the positive terminal of a battery to the terminal A and the negative terminal to B. You find 2 bulbs are glowing, that means the red and the yellow. Now I am going to change the terminal of the battery. Now negative is connected to A and positive is connected to B. In this case, yellow and blue bulbs are glowing. You have to tell me how these bulbs are connected in the circuit. Your time starts now.
I'm afraid the time's up. Both teams. No team going for the buzzer. Anyone in the audience with an answer? Nobody? Dr. Sanapati, I guess you'll have to explain.
Yes. Now this is a set of battery. That means it provides direct current. There lies the clue. You can stop direct current by placing a diode in the path of the flow of current. Let me remove this white paper. Then you can see that the red and blue bulbs are connected through diodes. When I am connecting the positive terminal to A and the negative to B, this diode which is connected to the red bulb allows the current to flow. But in case of blue bulb, the diode is in opposite direction, so it doesn't allow the current to flow. But the yellow bulb is directly connected to the power, so it always glows. When I am changing the direction of the current, in that case, in this case, the blue bulb gets power through the diode, and in case of the red bulb, it is obstructed by the diode. So that's the answer.
Well then, neither team daring enough to go for the buzzer. As we move on to the second last question of today's episode of Quest. Welcome back. With the scores reading 40 points for the C.V. Raman team and 30 for the girls of J.C. Bose team, we move on to the second last question of today's quiz, which is also on the buzzer. Breakfast with Dr. Sanapati. Yes, doctor.
There are 4 beakers. Okay. and the two at the middle are having raw egg in each of them. I am pouring 2 liquids in it. The egg on my left that floats, and the one on my right doesn't float. Why? Your turn.
The liquid on the right hand side beaker from the audience's side, that has a denser liquid.
Yes.
The density is more, so the density of the raw egg, the average density of the raw egg with its shell is lesser than the density of the liquid in that beaker. So due to the law of flotation, it floats, displacing the amount of liquid which is equal to the weight of the raw egg. In the other case, the liquid has a density which is lesser than the density of the raw egg. So the egg sinks, and because its density is more than the density.
Your answer is 100% correct. Nothing more to add to that.
We are into our last question, which is again on the buzzer. Scores reading 60 to the C.V. Raman team and 30 to the J.C. Bose team.
I have an object in my hand. Looks like a question mark. If you ask me to balance it, I'll do like this. That's not the question. If you ask me to balance like this, it's not possible. If I remove the thumb, it falls. Now, I'm adding a weight to this object. Okay. See, now I can easily balance it. What happens to this object, the question mark like object? When I add this additional structure, I am increasing the weight. Even then, it is balanced.
The center of gravity of the whole system moves behind, means below the finger. So you can balance it on your finger. But without that weight, the center of gravity is outside the finger. So
that's right. You know. Okay, let me explain.
Yes, Dr. Sam.
A body will be stable when its center of gravity is passing through the point of suspension. In this case, the point of suspension is somewhere here in my finger. And by adding this object, though I have added additional weight, but the CG of the whole system has shifted from this point to somewhere here, which is away from the point of suspension of the object. So now it is stable.
Let's have a big round of applause for the boys then. Picking up those 20 points, the C.V. Raman team gets an unassailable lead, and they finish with a final tally of 80 points. The girls, that's the J.C. Bose team, remain exactly where they were. We have a small memento from Quest. Well done, boys. Let's have a big round of applause for them. We hope you enjoyed being on our show, girls. Don't be disappointed. We hope you've enjoyed watching this show. Please write back to us with your comments if your school would like to take part. Our address is Doordarshan Kendra, Kolkata, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll be back with you again next week at the very same time. Till then, it's goodbye to you from the entire production team at Doordarshan Kendra, Kolkata.